You know, when you are like rushing through an airport to get to your gate and you glance up at one of those massive video walls?
Oh, yeah, those giant flight boards.
Exactly. Just dozens of individual screens completely seamlessly stitched together to form this one giant unified display. And I always wonder, what is actually sitting in a server closet somewhere making that visual magic happen?
Right, seems like it would take a supercomputer.
It really does. So today we are taking a deep dive into the hidden infrastructure of massive digital displays. And we are using some insights from a product page over at HDTVSupply for a device called the Smart-AVI MXWallPRO-4040-S. So, okay, let's unpack this because, we are talking about a $41,440 piece of hardware here.
Yeah, and for that price tag, you are getting something that handles a truly staggering volume of data. The MXWall Pro is an HDMI Matrix Switcher that can basically route up to 40 different video inputs to 40 separate screens simultaneously.
Wait, 40 inputs at 1080p resolution?
Yep, 1080p at 60 hertz.
That is wild. My laptop fan sounds like an industrial vacuum cleaner when I just try to run, two external monitors. How does a single box handle 40 simultaneous high-def video streams without just lagging out or, completely melting down?
Well, that is the core difference between a standard computer and a matrix switcher. A typical computer uses software to render video, right? So the processor has to constantly think and calculate and basically draw the pixels frame by frame.
Right, which takes a ton of processing power.
Exactly.
Hmm.
But this device does not think about the video at all. The heavy lifting is purely physical. It is entirely hardware-based switching.
So instead of software processing the data, it is kind of like the ultimate ultra-powered version of an old-school TV input switcher, like trying to connect 40 different video game consoles to 40 different TVs at the exact same time.
Yes, that is a great analogy. There is no operating system getting bogged down.
Oh.
The signal just hits an input card, travels across a physical backplane, and gets pushed out the other side.
Oh, wow.
And that hardware-level routing is exactly how it achieves zero latency. But it does more than just switch inputs. It manages complex layouts, too.
What do you mean by complex layouts?
So the hardware can take one single video feed, slice it up perfectly, and stretch it across all 40 screens as one massive canvas. Or, it can display 40 distinct feeds on 40 separate screens, all in real time.
If it is doing all that physical routing, like taking gigabytes of raw video and slicing it up, managing it must be a total logistical nightmare. I'm imagining a command center from a sci-fi movie just to get the screens to turn on.
You would think so, but actually the interface is incredibly lightweight. You do the initial layout mapping using a free Windows program.
Okay, a free program.
Yeah, and that lets you assign layouts, adjust aspect ratios, even upload custom logos. And for on-the-fly tweaks after that, you could just use a free Android app.
Hold on. Wait, so you are telling me you control a heavy-duty $41,000 piece of enterprise hardware running an entire airport's visual system with a free app I can download on a phone?
I know, it sounds a bit crazy.
That feels a little like locking a bank vault with a shoelace.
It totally sounds counterintuitive until you separate the control from the processing. See, the app is not actually touching the video data.
Oh, okay, I get it.
It is just sending a few bytes of simple text commands to the hardware, essentially just saying, hey, flip switch number 12. The heavy 30-pound plug-and-play metal box is doing all the actual work.
So the app is just the conductor waving the baton, but the hardware is the entire orchestra.
Exactly. And because those text commands need to be universally reliable, the device also supports legacy industrial controls like RS-232 and TCP/IP.
And those are the hardwired ones, right?
Yes, they are hardwired, fail-safe communication standards. They do not rely on a spotty Wi-Fi connection, which is mandatory, because these units go into security stations, air traffic control centers, and arenas.
Places that can never go offline.
Right. They have to run 24 hours a day, 7 days a week. A software crash in those environments is not just annoying, it is a critical operational failure.
So the next time you are standing in a huge public space, bathed in the glow of a perfectly synchronized video wall, look past the pixels.
Yeah, you are really seeing the tireless real-time work of a massive 2-rack unit matrix switcher hidden in a back room somewhere.
Just instantly snapping physical electrical pathways into place.
It definitely peels back the curtain on the digital architecture of our cities.
It leaves you with something to chew on, too. As our physical environments become increasingly covered in these massive 40-screen digital canvases, Who's deciding what actually gets routed to those displays? And how much of the physical world around us will eventually be managed by someone quietly tapping on a single Android app?